Hello, everyone. I'm Michaela Parker. I'm the founder and executive director for the Academic Data Science Alliance, or ADSA, and I'm here to welcome you today to our Listen and Lunch AI webinar series, where we bring you experts from around our community to share their approaches to incorporating AI in teaching and research in higher education. Today, we will hear about the National Research Platform, which is a nationwide collaboration of over 50 institutions providing free access to advanced AI computing resources and infrastructure for education and research. Its education arm supports more than 2,500 students from across 70 courses, and Frank Würthwein, who's joined us today, will share how educators can leverage these resources to power AI and data science programs at virtually no cost. And a quick reminder that this event, like all ADSA events, is governed by our ADSA Code of Conduct, which you can find linked at the QR code on this slide. But first, before we get started, and for those of you who are not already familiar with ADSA, we are a community for data science and AI leaders, practitioners, and educators who believe in a just, equitable future where data science approaches are thoughtfully applied in all domains for the benefit of all. If you're interested in learning more about our events and activities like this webinar, you can use that URL on the slide to get to our homepage, and also you can access it with the QR code from your mobile device. Okay, now I am delighted to welcome Frank Würthwein, who is the director of the San Diego Supercomputing Center. Würthwein leads the distributed high throughput computing at SDSC, and he is a faculty member in the UC San Diego Department of Physics, as well as a founding faculty member for the Halajolu Data Science Institute on campus. His research focuses on experimental particle physics, and in particular, the compact muon solenoid experiment at the Large Hadron Collider. He continues to serve, as he has for many years, as executive director of the Open Science Grid, the premier national cyber infrastructure for distributed high-throughput computing. Thank you for joining us, Frank, and welcome. I'll pass the baton to you.
Many thanks for inviting me. And let me do the sharing magic and see if we can make this work. And we go here. And then do you see my slides in the right way?
Yes.
Okay. So I gave this the title AI Infrastructure for All, which will become clear in a moment. If you look at this from a national perspective, I'm showing here some data from the Department of Education website. And in the 23-24 academic year, there were about 20 million students in college in the US, and there were about 3,580 nonprofit colleges total. Out of these 20 million students, 40% are in community colleges, 43% in four-year colleges, and 70% in graduate and professional schools. So if you take this as a starting point and then ask yourself, how many of these would want, need, desire AI education in some form? I'm taking the following approach here. I either take a survey result from San Diego State University or the actual use at UC San Diego undergrads, and I arrive at something between 5 and 10 million college students. So I'm working on the assumption that somewhere between 5 and 10 million college students have a desire, a need for AI education, or more broadly, for digital assets in the classroom. Because I make the fundamental assumption that AI is an experimental science that you cannot teach on the blackboard. It makes no sense to teach it on the blackboard. You have to bring in digital assets into the classroom. And this is what this is all about. So what do we do at UC San Diego? We've started bringing digital assets into the classroom in 2017. What you see here is the quarter by quarter, we're on a quarter system, is the quarter by quarter use of digital assets in the classroom, where digital assets literally means a GPU cluster plus 500 terabytes of disk space. And if you look at just the last quarter in the last academic year, there were 18,963 students enrolled in courses that required this infrastructure. And if you then look at that's where the 24% comes from. And if you look at how many courses there are 132 courses, 81 instructors across 8 of our schools. And if you sort of look at the fine structure, this here is the green in is engineering, then comes social sciences, then comes data science, and then comes biology, and then a bunch of smaller things that sort of change from year to year. So the big ones are engineering, data science, engineering, social science, data science, and biology at this point in time. And it's changing, and as you can see from the progression over the years. So what I see when I look around at my own institution and then look around at the institutions that we work with nationwide, I see the beginning of a revolution in education. I am willing to go as far as saying that 10 years from now, institutions that cannot offer digital assets in the classroom will be struggling and going out of business, because education will be considered subpar unless it offers, in some courses at least, digital assets in the classroom. And the reason I think that drives us there is, first, AI redefines what's possible to teach in a classroom, and I'll give you a couple examples. And second, the how we teach and not just the what we teach is changing. AI makes personalized tutoring before, during, and after the classroom session possible. The most advanced institution I know of is probably the University of Michigan, where students get an AI tutor the moment they sign up for and get the email address. So with your email address, you also get your personal AI chatbot that you then work with for the rest of the 4 years of your college. And I think that this is the future for all institutions. And so, but let me show you a little bit more on redefining what's possible. On our, we have this infrastructure for the university, and then we have an identical infrastructure that we run for the nation. And on the national infrastructure, we have customers from all over the place. And one of them is Carl Bertiger from Berkeley. And he teaches this class with 122 students where he does coding with large language models as part of the in-class exercises. In particular, he challenges in an active learning classroom environment the students to visualize the Manhattan skyline in 3D. And down here in the corner, you see that it's actually working. This is the actual notebook that they use in their class. In order to do it, what they do is they connect to an LLM as a service that we operate, and he then tells the students to ingest 2 software packages, or the documentation of 2 software packages, and voila, magic happens, and the LLM that is vanilla, basically an open weight LLM, one of the open weight LLMs that we support, suddenly can do this and knows how to visualize Manhattan in 3D via just dumping into the screen an executable script that comes to the Jupyter notebook via the Jupyter AI interface. And this is the kind of things that is just totally unimaginable if you don't have digital assets in the classroom. And this is the kind of thing that I believe revolutionizes education, because the unthinkable is now possible. And in Carl's case, it was just LLM as a service. In essence, he could have just done this with OpenAI and paid an arm and a leg for it. He's using us because we're free. But we want to go beyond what OpenAI offers. We want to streamline access also for much larger data sets, for much more complex AI workflows. And the first 2 examples come from my own institutions that I know of. There's and you see them on the side here. What we ultimately want to accomplish here is give instructors the means to build DAGs on the fly for their own courses, do agentic AI systems, build all kinds of things that build embedding spaces ahead of time that the students can then work with, and work in vastly larger, in like hundreds of terabytes it's data sets inside the classroom. The sky's the limit of what you can imagine, basically. So now, what's the challenge what's the biggest challenge in order to make this happen? There's sort of two types of challenges. One is just curriculum, and we see this adopted already like a wildfire. It's spreading like wildfire. And the other challenge is that operations is expensive, and unless we do something dramatic, we will lose the vast majority of those 3,580 colleges because they will not have the access to do this kind of thing. And it's not about hardware ownership. Hardware ownership is cheap in comparison. It is about operation support. The vast majority of these colleges are not R1s. They don't have the scale of research and computing at their institution that would warrant to have clusters. And therefore, they don't have the means, the scale, the personnel to run cyber infrastructure. And so what if we aggregated the system administration, cybersecurity, and the user support across 1,000 colleges and literally did what the hyperscalers do, but do it for all of education together, and do it in a way that the things that scale well as a function of amount of hardware that you support, and therefore bring the price down the more hardware you support with a fixed set of people, and bring this to all of the nation. And this is exactly what we're doing with NRP. We have a prototype that is funded right now by the National Science Foundation that we will get to about 100 colleges. And I'm shooting for tens of thousands of students using digital assets in the classroom. And this is what we offer today. We run other people's hardware from IPMI up. In other words, all the institutions that are required is rack up the hardware, connect power and networking, make sure that they have the kind of networking environment, work with their local network provider in order to make this happen. And then we take on everything else. The researcher and educators and students see a global scale Kubernetes cluster. They see Jupyter hubs. They can choose to either work at the kubectl level or at the Jupyter level. Most of the educators work at the Jupyter level. And we have lots of software to reuse. We have sort of a water cooler effect because people can share their notebooks that they've used in various classes. They can share syllabi, etc., etc., etc. They can share experiences. They can talk to each other. We maintain a topical chat channels. We run something called Matrix. Matrix is a Slack open source version, an open source Slack version. So we effectively run Slack channels, but they're open source, and we have the full history of these Slack channels. And therefore, we can actually use them in AI bots. And we've started doing this. We started feeding the community information in these chats into bots in order to support the community more. We provide LLM as a service. For every course that we support in our infrastructure, the educator gets a chat channel so that the educator can talk to their students. At the same time, there's an educator chat channel so that the educator can talk with their peers and exchange information. How did you do this? Wow, this is great. Can you show me how to do this? That sort of thing. And finally, this AI workflows via NDP. I'll skip this. You can look at this as later. This is sort of the scale that we have. As of right now, we manage hardware in 101 data centers across the world, mostly in the US and mostly on this map. And if you go to this URL, you can actually click on these flags and you can zoom into your heart's content, zoom out to see other places in the world where we have a presence. And when you click on one of these flags, it will show you what is actually installed in that location and get a little bit of a sense. Maybe there's already something installed on your campus. And I wanted to walk you through an example of an institution that has been at this for now, I want to say somewhere between 2 and 3 years. And that's the CSU San Bernardino. CSU San Bernardino is not an R1. It has 19,000 students, 1,100 faculty members. It is a predominantly Hispanic serving institution, 57% Pell Grant recipients. It's A typical R1, maybe one of the larger ones, if you at that. Oh, sorry, a typical non-R1 institution, maybe a larger one at that. In CSU San Bernardino, they have a Jupyter Hub where they started out with our Jupyter Hub. We run a Jupyter Hub for the nation to get started. And then they found that this is so powerful for their institution that they are now run almost a dozen Jupyter Hubs for their own institution. And they run one for the entire institution where people get to sniff into it. It's connected to the institutional logon. It is integrated, branded for their institution. It looks like it's theirs because it is theirs ultimately. On their hardware, we just run it. And then they have created for all of the labs that do research on our infrastructure, dedicated Jupyter Hub. They do all of their research in Jupyter. They do all of the education in Jupyter. They have brought a education resource that then also is used in research, and the two intersect and make it easier for faculty who are predominantly teaching faculty to do some research on the side. In 2024, they consumed almost 100,000 GPU hours at a non-R1. There aren't that many non-R1, I postulate, that consume 100,000 GPU hours in a year. There's also the San Diego Community College District active. And I want to say a little bit more about the state of affairs in California. Community colleges have a special role to play and are particularly important for both the University of California and the California State University system. California has a three-legged public higher education infrastructure. Community colleges for 2-year, CSUs for 4-year, both of them are non-R1s, and then the UCs for PhDs. And there is a contract negotiated via the governor that 30% of the graduating class, if you wish, meaning the incoming class every year, are graduates from the community colleges. So UCSD has 2 threads of students that enter UCSD every year. There's the first years and there's the third years. And the third years are all from community college. And we guarantee that 30% of the incoming class every year is from community colleges in California. That's part of our state mission. And for the CSUs, it's even 50%. So there's a great interest to bring the friction for this transition from community college to PhD, basically, as small as possible. And so the community colleges are a crucial audience for NRP because it simplifies the trajectory. If the community colleges have the same kinds of opportunities in digital assets in the classroom as the UCs, then you have this transition that is actually possible. Now, how do we want to scale this out nationally? Well, we want to rely in part on ATSA and in part on the research and education networks. The way that I think about this is when you look at what you have to accomplish in order to make this happen, you have to come in by the network. You want to attach yourself to the CIOs who pay the bills, but you also have to come in by the curriculum. ATSA brings us to the curriculum at these institutions, and the research education network, the people who bring the internet to academia, they bring us to the CIO and from the network side. And by coming in both directions, we have a chance to most effectively bring in and bring this to a new institution. In California, this means CENIC. CENIC has these kinds of charter members. In CENIC, in California, this also includes the K-12 and the public libraries. So at some point in the future, we expect that we will hit not just the community colleges, but by the community colleges, the high schools, because at least in California, there is a very strong tie-in between the community colleges and the high schools, such that AP courses in some cases, or college courses more general at the high school are taught by the community colleges. And there's therefore a very strong binding. And we will explore this in the future. This is where we're at right now. There's close to 1,000 GPUs on CENIC. I wanted to show you some pictures because all of this is abstract unless you see the pictures of the people inside the data center where we've deployed stuff. Basically, all of these pictures were taken when Tom DeFanti drove around, brought them hardware, and then plunked the hardware in. And the way that when we actually deliver hardware like this, we literally, within an afternoon, the college is up and running and is inside the Kubernetes infrastructure, and voila, we are ready to roll, and they can use it for the college. In addition to, so I've told you now that education pays the bills for the vast majority of colleges in the United States. I've told you that research comes for free as a rider on the AI education infrastructure. And I'm going to tell you that there's one more side effect, and that side effect is in research and engagement with industry. We have learned recently that, well, actually, within this year, we saw 2 examples where we find that we can facilitate research engagement between non-R1s and their local industry. And we're doing this right now in 2 places: in agriculture technology, where we're instrumenting the Iron Horse vineyards in Sonoma, and in fusion energy, where we facilitate a collaboration between CSU San Bernardino and San Diego State University and General Atomics. You may have, those of you who pay attention to this sort of thing, there's an enormous buzz right now that the fusion industry will scale out by a factor 1,000 within the next decade or 2, from about $1 billion economy to $1 trillion economy. That kind of scale out requires an awful lot of human resources and workforce. And so we're starting to build those workforce via the practitioners in fusion and the non-R1s in California. And I want to show you some pictures of the Iron Horse vineyards. This is real. What you see here is, you see John Graham here and Tom DeFanti literally working with the vineyard and instrumenting the vineyard, flying drones, riding a 360 video taking and e-bike, deploying cameras to observe 360 degrees for wildfire detection. All of this is real and was literally happened within the last 2 months. So where do we go from here? Where we look at this as a scale out in 3 phases. We're in the midst of phase 1, which is fully funded by the NSF. Our goal within the next 2 to 3 years is to scale out to 100 colleges. And I promised the NSF 10,000 students that would be enrolled in classrooms on the infrastructure. I think I'm going to beat that by a factor of 2, 3, 4, 5. Not clear yet. Given that UCC alone has 19,000 students enrolled last year, finding among these 100 colleges 10,000 students who enroll in classrooms that use digital assets on our infrastructure seems like trivial. Then there's a phase 2 where we turn the infrastructure from something that is sort of best effort beyond 9 to 5 into something that is 24/7, because we realized already that outages that last a few hours are totally acceptable for a research infrastructure. The NSF requires 95% uptime for its systems. And 95% uptime is totally unacceptable. It's way too little for a college that depends on this as their education infrastructure. Just imagine a lecturer depending on digital assets in the classroom, and then suddenly nothing works. It's a nightmare. And so we have to transition to 24/7 support, at least for system and cybersecurity. But we will probably stick to 9 to 5 for user-supported training and only have the chatbots alive at Sunday evening in the middle of the night. And then we have a phase 3 where I've come up with a business model and convinced myself that this is actually sustainable, self-sustainable via a membership of about $10 per student per year. And I consider $10 per student per year free, because textbooks are 10 times that expensive in at least my field. And while I call it the beer a year per student program, because a beer in San Diego costs about $10. And I don't know any student who drinks beer who just drinks 1 beer a year. So this is free. Finally, my summary and conclusions. This is when everything's said and done, in my mind, I'm doing this in part because I actually find this is fun. I think that building infrastructure and scaling it out to 1 million students across 1,000 colleges is one hell of a ride. And I'm looking forward to making this happen. And so for me personally, as a supercomputer center director, this is just a lot of fun. And that's why we do it. But behind there, in the back of my mind, the driving force is social mobility. When I look at the United States of America today, one of the cardinal sins that we have is our ability to provide social mobility, to provide everybody a level playing field of opportunity has decreased. And the only place left where I see social mobility as a driving force is education. And if education goes through the revolution that I mentioned, that I believe it is going through right now, and therefore as a result turns the education at thousands of colleges into subpar education, that is not what we want. And so my driving, what drives me beyond having fun is that I want to provide social mobility via education, via digital assets in the classroom at every college in the country, such that they can own it, not that they can rent it. And ownership to me is essential, because ownership empowers you and changes the way you operate, because ownership of infrastructure will then allow you to also offer it for free for your faculty for research, and offer it for free to your engagement with industry, and do engagements with industry that help you pay for this infrastructure potentially, for owning this collectively as a community. And that's why it's so important to make this an ownership infrastructure and not a rental infrastructure. Thank you very much.
Thank you so much, Frank. That was wonderful. I know we're almost out of time, but I want to provide a little bit of space. If anyone has any questions, we're a small enough group. Feel free to unmute and raise your hand. And while folks are thinking of a question, I did want to ask, Frank, are you willing to have these slides be available to the registrants? I know you have provided some links in there.
Yes, I think that, in fact, this is a subset of slides that I've presented as a keynote at ICPP, an international conference less than a month ago. So I am perfectly comfortable for you to share it with anybody you want.
Oh, fantastic. Yeah, that would be great. I appreciate that. And just very quickly, I know we're out of time, so if folks need to leave, that's the go ahead and sign off. But I did want to ask very quickly, because I suspect for especially the folks in the room that are in any kind of leadership position at a school and are hearing this and are thinking, well, I'd really like to be part of this, especially if there's still funds available from the NSF portion of the phase. Where do schools get started? They're interested in learning more. They want to know, what is the bottom line in terms of investment of time and cost? Where do they go from here?
So let me first stop sharing so that I can more easily find the chat, and then type my email address.
Great.
If you send me email, I will point you in the right direction. And this is you're not imposing at all. I do this all the time. I got an email just from CSU Bakersfield a couple days ago, where and it doesn't have to be institution-wide. In CSU Bakersfield, the people that contacted me is an AI and data science initiative inside their campus. They already bought the equipment, but they are struggling to operate it because they don't have the means to do so. They heard a similar thing that I gave somewhere else, and voila, we're connecting, and we will take over operations for their hardware, and we will work with the networking provider to make sure that they have the necessary network capabilities to make this all work.
You mentioned delivering hardware at one point in your presentation. Is that I assume that's not a typical arrangement? Or
yeah, it's not a typical arrangement. We had at some point a few years ago, we had SICE funding, which included hardware. That and SICE was very flexible and allowed us to deploy this hardware anywhere we wanted. And so literally, and I'm right now in negotiations with both Cisco and Dell, and I'm basically trying to find funders out of the tech industry that are willing to give me free hardware. And if I were to able to get that, then right now I'm basically broke. I don't have any more free hardware. But I'm trying to get more free hardware so that we can actually send this around and seed fund things, because the first thing that I can guarantee that you can just access the infrastructure as is. You don't have to have hardware in place. That's the first thing.
That's a good point for everyone on this call.
Yes.
Keep
So
that in mind if you want to test it out, right?
If you want to test it out, you can and get on immediately. The second thing, and we have a number of training materials online that we can point you to, and we have I think every other week a 1 hour open house. We basically have an hour where an office hour where you can just pop in and say, oh, I want to learn how to do this. Where do I get started? And somebody is there to just wait for you on Zoom, basically. And so there is, if I succeed in talking, weaseling hardware out of Cisco or Dell or one of the other tech companies, then I will be sending more hardware around by car or
great.
And it makes a huge difference. We've been doing this for a few years, and when you send by mail hardware, it sits in somebody's office for months.
Yeah.
Whereas if you just show up and unload from your back of your car and literally walk in and the people are ready to deploy, it is instantaneously available. And so we actually have stopped sending things when we can and just drive there. And Tom DeFundi has literally driven all over California, all the way to Cal Poly Humboldt, which is the other end of 1,000 miles away from us, the other end of the state. So it is a very, very effective way of getting things going.
That's fantastic. I mean, I could envision other nodes around the country that could be delivery points as well, since obviously you're not going to drive to the East Coast.
Exactly. And we have very strong relationship in the Midwest with the Great Plains Network. Part of our operations actually run out of Nebraska, the University of Nebraska-Lincoln. And so we have strong relationship to New York, NISANet, to MCNC. So there's a variety of different places around the country where we have fairly strong relationships that one could probably do similar things or have somebody provide support that is more local than us in California.
Yeah. That's great. Okay, I know we're way over time. I think I got your URL right, nrp.ai. Is that where folks can go to find the office hours that you refer to?
Yeah, in fact, if you go to that website, there's there is a flag on the top which advertises October 20th is our next office hour.
Great. Well, hopefully some of you will join that office hour. And thank you again so much, Frank. I want to let the audience go. Very much appreciate this. I know there's already folks asking to learn more, so you might expect some emails. And have a really great day. Thank you, everyone.
You too.
Have a good day.
Bye.